large recreational facility, and this one happens to have an ice rink that you see behind me. So some of these facilities may have an ice rink year round like this one, and some of them may have it intermittently where they'll get rid of it and put a basketball court or a concert arena. You may have seen something similar, but because this one runs year round, it's important to understand how this is created and what it actually takes to maintain it. So this particular ice rink here is a very simple explanation of how it's put together, but it's actually a two-loop system. So we have just a subfloor, we have a first loop that is running a refrigeration through it, and it's keeping the subfloor warm. Then we have some more insulation, and then we have a second loop that actually keeps the ground cold. And this particular ice rink, that loop is actually embedded in a layer of concrete. And that concrete is what our sub is that starts to create the ice. So that will actually cool this concrete up and then the ice will form over it. This rink here actually takes almost 12,000 gallons of water just to get an inch of ice, and that can take up to 3 days to do that process. So you can imagine the maintenance it takes to go into a process to even get to where we are right now. And all of that actually takes place in that room back there where our chillers and pumps are. So let's go ahead over there and let's discuss how this process works and what you can look for as an inspector to ensure the system is operating properly. Next, let's talk about the refrigeration system. So back there in that room, we have two different systems that are actually keeping this ice rink cold. Remember I said we have that first loop layer? Well, that first loop layer is actually warmed through a refrigerant that is created into evaporation and steam. And then our second loop layer that's embedded in the concrete, there is a bromine solution that runs through that with a chiller tower and a pump system that you will see. There is a lot of maintenance that goes into those type of systems that keep it operating. As an inspector, there's only a few things that you can really do outside of just looking at it physically or visually. We're going to look for data tags. We're going to look on the data tags, obviously, and remember that's going to help us understand what system we're looking at, how old it is, what type of maintenance might be necessary for it, so that you can actually see, okay, this is the chiller, oh, this is a pump, this is what refrigeration is running through. And in some circumstances, it could be an older system still, say, running like R22 or another outdated refrigerant. It's good to note that inside your report. Now, visually, the things that you can really assess are going to be, say, leaks or damages to any unions or pump connections. If there is anything like that, it's important to go immediately tell someone on the maintenance team. Here, they have a really robust maintenance program that keeps this ice rink looking great, but it's possible that you could go to a building that doesn't have a stellar program in place. If they don't, and you see some sort of leak, it's possible that that is a refrigerant leak, and that can cost them thousands of dollars to get remediated. So make sure as you move around that room, keep an eye for anything that looks out of normal, and keep to your original intuition as an inspector. You're already going to see the visual defects we always find. This is just a simple chilling system. It's very simple to something smaller. Just because it's bigger, don't get afraid. Okay, so it's important to understand that to maintain this ice as it is now, there's a few different aspects that have to be taken into consideration. So this ice actually has to be kept around 15 to 20 degrees so that it can stay at this consistency. Um, I've actually been told that the ice, if it's used differently, so for example, if you are an ice hockey team, the ice actually would be a little bit warmer temperature so that they can actually dig their spikes into the ice. And then if you are a figure skater, like you might see behind me, that the ice actually needs to be colder. So that's not really something to determine. It's just kind of a cool fact to understand that this needs to at least be a certain degree so it can stay ice. But then alongside that, we have to think of the actual ambient temperature in the building. So they're going to have a heating and cooling and a dehumidifying system so that this property can actually stay the right temperature up here alongside the ice so that we don't have any issues with the ice where humidity actually starts to build around the ice surface itself and start to cause moisture damage to the actual surfaces around. If you're ever in the building like that and you're doing your visual inspection and you start to see corrosion or mold or anything, then they may have humidity issues, and then they may have issues with their dehumidifying system, or they may not have a dehumidifying system at all. And that's important to at least pay attention to. Now, on the outside of these windows here, it looks like my cooling tower. So when I leave and I go looking on the outside, I at least want to try to get to that point so I can evaluate the rest of the system. So it's important to take into consideration there's a lot going on just to keep what we see going consistently. In summary, remember, just follow section 6 of the ComSop. You already know how to do your normal inspection, right? We have walls, we have windows, we have electrical, HVAC components, some life safety things. I see fire extinguishers, things of that nature. You already understand how to inspect. Knowing that an ice rink obviously is outside of our ComSop, it's so important to understand why it's here and how it's operating because there's some secondary things to pay attention to. For example, back in that mechanical room, you have to think of occupant and life safety aspects. We have fuel storage in there. We have large scale electrical and mechanical systems. All those things have to be evaluated. Use your senses and understand, is something safe or something not safe? It should be visually able to understand that. And then inside that room is pretty loud. Obviously, on that door, it says you may want to use some sort of ear protection. I recommend doing so. My ears are still ringing now just being outside of the room. Remember, use your basic instincts. You already know how to do an inspection like this. It might seem scary. Some of these systems are really large, but they're not as big as you think once you understand the basics and how these operations work.